This is our trigonometry section 6.1, part 2, where we will be evaluating functions and identifying the 6 trigonometric functions and various problems. So in example, we've done already 1, and we're now going to go to example 2. Given that the sine of alpha equals the square root of 15 over 8, and cosine of alpha equals 7/8, and tangent alpha equals the square root of 15 over 7, we're going to find the cosecant alpha, secant alpha, and cotangent alpha. To find the cosecant alpha is equal to the reciprocal of sine alpha. So we just take the reciprocal, which is 8 over the square root of 15. The cosine alpha is 7/8, so to find the secant alpha, we take the reciprocal of cosine, and we have 8 over 7. And then to find the cotan of alpha, we take the reciprocal of tangent alpha, which is 7 over square root of 15. I did not go further and rationalize the denominator, but you can do so by multiplying by the square root of 15 over the square root of 15, and you get 7 square root of 15 over 15. In example 3, given a function value of an acute angle, we're going to find the other 5 trigonometric values. So I did an example here where sine of beta equals 6 over 7. So we sketch beta in a right triangle, and since sine is opposite over hypotenuse, we know that the side opposite B is 6, and the hypotenuse, which is the side across from the right angle, is 7. And so we can use the Pythagorean theorem to find the other side, to find A. And so we have 7 squared minus 6 squared equals A squared. A squared is equal to 49 minus 36, which is 13. Then A is plus or minus square root of 13. Because it's distance, we see that A has to take on just the positive square root of 13. And now we can find the other trigonometric functions now that we have all 3 sides. So we already have the sine of beta given. The reciprocal function cosecant of beta is 7 over 6. Cosine beta is adjacent over hypotenuse. So the adjacent to beta is that square root of 13 over 7, which is the hypotenuse. And then the tangent of beta is the opposite of our angle beta. So opposite is 6 divided by square root of 13, which is the adjacent side. And the reciprocal function for cosine is secant. So secant beta is 7 over square root of 13. And the cotan beta is reciprocal of tangent, which is square root of 13 over 6. So we'll do a couple of these together. We have the tangent of phi equals 10. Now we know that, let's go ahead and write this as a fraction. And the definition of tangent is that is opposite over adjacent. So sketch a little graph. Maybe sketch a little better than the one I just did. Try to draw a right triangle. So if I make this phi, then my opposite side will go across from that. That will be 10, and my adjacent is 1. Using Pythagorean theorem to find C, we have C squared equals 1 squared plus 10 squared. I'll go ahead and do that on my calculator. So 1 squared plus 10 squared is equal to 101. So C is the square root of 101, which is 10 point, actually we could just leave it as an exact number. So C is the square root of 101. And now we can find the rest of the trig functions. So sine of phi is opposite over hypotenuse. So that's 10 over square root of 101. The cosine is adjacent over hypotenuse. We already have the tan. We'll go ahead and get the reciprocal function. So the cosecant of phi is equal to square root of 101 all over 10. And then the secant phi is equal to the square root of 101 over 1, which is just the square root of 101. Let's see, we have the cosecant theta is equal to 1.6. If we want to write 1.6 as a fraction, that would be 8 over 5. Sketching a graph. We have a right triangle. The theta is here. Cosecant, the definition of cosecant, well, that's the reciprocal of sine, which is opposite over hypotenuse. So we take the reciprocal, and that's hypotenuse over opposite. So the hypotenuse is 8. The side opposite of theta is 5. And so to find out what is A, we get the square root of 8 squared minus 5 squared. Which is equal to, well, we can get it exact as well. So 8 squared is what? 64 minus 25 is 39. So A is equal to the square root of 39. And now we could find the rest of the 5 trig functions. Let's see, we have cosecant, so then we should be able to get sine of theta is equal to 5 over 8. The cosine is equal to square root of 39 over 8. And the tangent is equal to 5 over square root of 39. We already have the cosecant. The secant is the reciprocal of cosine, which is 8 over square root of 39. And then the cotan is square root of 39 over 5. Okay, this last one, cosine alpha equals square root of 7 over 7. Let's see if we can simplify this a little bit. What if I were to multiply the square root of 7 over the square root of 7? We would have 7 over 7 squared root of 7, which is 1 over square root of 7. Simplifies that a little bit. Sketching our graph with the ratio of the sides. We see cosine is adjacent over hypotenuse. So that's the square root of 7. The adjacent is 1 if I put alpha here in the corner. And then we just need to solve for A. using the Pythagorean theorem. So a is equal to the square root of square root of 7 squared minus 1 squared, which is equal to square root of 7 minus 1, or the square root of 6. And then you can find the rest of the trig functions. I think I'm just going to go ahead and skip down to our special triangles. These are special because the 45, 45, 90 degree angle, this is a isosceles triangle, and where you have two bases that are exactly the same, in which case then their opposite sides are also the same. So this is a ratio of 1 to the square root of 2. So the sides are 1 and the hypotenuse is the square root of 2. And these are ratios, so it could be really any multiple of 1 square root of 2. So I'm just going to say times x. In the 30, 60, 90 degree triangle, the ratio of the sides of a 30, 60, 90 would be 1 square root of 3, 2, where 1 is across from the 30 degree angle, square root of 3 is across from the 60 degree angle, and the largest side is across from the hypotenuse, that's 2. And again, these are all like multiples of, because these are just ratios, so we can actually multiply each of these by x and still have a special triangle. So we like to break it down to just, the, if we can, 1 squared to 2, if we have to draw the triangle, we would just break it down to those ratios where x is equal to 1. So in example 4, we're going to find the exact value of the cosine of 45. So what I would do is sketch a triangle, a 45, 45 triangle, 45, 45, 90. And so with that triangle, we know that the legs are each 1, and the hypotenuse is the square root of 2. And the cosine of 45 is adjacent over hypotenuse, which is 1 over the square root of 2. The sine of 45, I could just use that same sketch. I just go across from the 45, and we see it's also 1 over square root of 2. For the tangent of 30, I'll need to draw another sketch. So here's my 30. So in this case, we have a 30, 60, 90 triangle. And the ratio of the sides are 1 square root of 3, 2. Starting from the side across the smallest angle. So the tangent of 30 is opposite over adjacent, so that is 1 over the square root of 3. And the secant of 60 degrees, well, I'm going to go ahead and use the, we know that's the reciprocal of cosine. That's 1 over the cosine of 60. And the cosine of 60, if we take a look at this angle up here, the adjacent side is the 1, and the hypotenuse is 2. So the cosine of 60 degrees is 1 over 2. So the secant then has to be 2. 2 over 1, or just 2. Let's see, we have the cotan of 60 degrees. That is the reciprocal of the tangent function. So, or you could just memorize the fact that the cotan, instead of opposite over adjacent, it's adjacent over opposite. So sketching a 30, 60, 90, if this is 60 degrees, and I know my sketch is not pretty, but let's just assume 60 degrees is the larger angle. Across from the 30 is 1. Across from the 60 is the square root of 3. And then the hypotenuse is 2. So the cotangent is 1 over 2. Because again, the angle in question is 60 degrees. And the side adjacent is, sorry, it's not 1 over 2, is it? Erase that. Okay, so we have the adjacent over the opposite. So our answer is 1 over the square root of 3. In all of these problems, I'm assuming that you could go ahead and rationalize the denominator. You can do so just by multiplying by the square root of 3 to eliminate the root in the denominator, and you get the square root of 3 over 3. For the sine of 30, I guess I'll just go ahead and use a different color highlighter, and we'll use 30, okay? So the sine of 30 is, we know the ratio of the sides is opposite over hypotenuse. So the opposite of 30 is 1, and the hypotenuse is 2. So we get 1/2. Okay, so we can also use special angles or special triangles to find the exact angle now. So here we have the ratio of the sides. So what I would do is sketch a triangle, a right triangle, not knowing what the angles are. Don't worry about its accuracy because we will just put the ratio of the sides. So the theta in question, the sine of that angle is the square root of 3 over 2. So the opposite side is the square root of 3. Hypotenuse is 2. So this is a 1 square root of 3, 2 triangle, which is a 30, 60, 90. We know that. Now, the, let's see. So the angle then is across from the larger leg. So that means the angle is 60 degrees. Let's see, the cosine is 1 over 2. And the cosine, the definition of cosine is adjacent over hypotenuse. Over here, the sine was opposite over hypotenuse. Okay, so we're going to sketch another triangle where you have theta in one of the angles. The adjacent side to that is 1, and the hypotenuse is 2. And again, we have a 1 square root of 3, 2 triangle where theta is equal to 60 degrees. We can verify this using our calculator, actually, by taking, this will come a little later in chapter 6, where you take the arcsine. So if cosine theta equals 1/2, we can take the arcsine. So that's the cosine to the -1. That's the arcsine of 1 divided by 2. And we have 60 degrees. If you wanted to check A, we have the arcsine of square root of 3 divided by 2, and we have 60 degrees. This only works if you're looking for, well, if you want to express the angle in degrees, make sure you put the mode in degrees, where it says radian or degrees. All right, we'll be switching back and forth in this class to that, but for this exercise, we have it in degrees. The tangent theta is square root of 3 over 3. Again, I would try to simplify that, because right now I recognize the square root of 3, but 3 is not one of our special ratios in our angles. So I'm going to multiply by the square root of 3. I'm basically rationalizing the numerator so that I can express this. Let's see. So we have now 3 over 3 square roots of 3, which is 1 over the square root of 3. And now I can recognize that we have a 1 and a square root of 3 in one of our special triangles. So it says the tangent of theta, that's the opposite of the theta. So that's 1. And the square root of 3 is the adjacent. Okay, so it's O and that's A. So the adjacent is square root of 3. So now we have a 1 square root of 3, 2 triangle. Theta, because it's across from the smallest leg, we know theta is equal to 30 degrees. And again, you can check that on your calculator by doing the arctan. So second tan, and you're going to put the square root of 3 divided by 3, and we have 30 degrees. Let's see, in part D, we have the cosecant theta equals 2. So the cosecant theta, the definition of cosecant, it's the reciprocal of sine. So we know the opposite is in there. So that's, if we put it over 1, that's hypotenuse over opposite. That's the reciprocal of sine. So putting in our theta, our hypotenuse is 2. The side opposite the angle is 1. So this is a 1 square root of 3, 2 triangle. Since theta is across from the smallest side, we have a 30 degree for theta. So I'm going to stop here to keep my video short, and we will continue with part 3 using finding degrees, minutes, and seconds.